side. I would like to now maybe invite the European speakers to explain what the use cases and requirements are seen from Europe. First, I would like to give the floor to Pertti Johainen from DG Connect with the European Commission views on the priority sectors for these future mobile technologies. As we have 4 speakers in the European use cases session, I would like to ask you to keep an eye on the clock. But Pertti, now it's your time to shine, so the floor is yours. Thank you very much.
Okay, very good. Now, good morning, good afternoon. Sorry. My name is Pertti Johainen, and I'm working in the Future Connectivity Systems unit as Bernard Barani, who already presented the vision, so to say, and the policy context for the beyond 5G, 6G perspective. And I would here like to emphasize a little bit what the requirements and the use cases that already Bernard outlines, so to say, from the European side, and then the initiatives that we're doing towards 5G, beyond 5G. As had been said, also from the Korean side, we see that very much, I see the slides is not perfect, so the display of the slides. But we see already in the 5G aspect, when we look at 5G, from 4G, 5G, we see the potential and that it has been created, so to say, from the technology side. We see the smaller 5G going into many sectors in society, in our economies. We see the value of the economies going increasing, so to say, and this is only in the start now. We see 5G technologies coming out. We are not finished with 5G yet, also from a standardization point of view. So it's still so many aspects still to be developed and deployed, so to say, in the society and our industry. But we see the role that the connectivity has, and now we are going from the mobile broadband into the vertical sectors, and this is a big step with 5G getting integrated into the sectors, and we see the economic values increasing and the potentials have been very high, so to say, and you see that from the 3.8 trillion to 11 trillion by 2025 that McKinsey outlined some years ago now. So it's a big potential, so to say, economic value. So, and also the ICT sector is increasing its global value in the global economy. We are maybe 4 or 5% now, and maybe up to 11% in 2025. So this is really going into the so the sector is indeed increasing, and we see the importance in the pandemic times, of course, of connectivity. On the left side, you see also the integration of connectivity in the industry sector, so to say. Today, there are maybe 7 million global base stations, so to say, but in 2025, the levels will be double, so to say, 14 million, so to say, and there are many in many important industrial sectors there. The connectivity is getting more and more important, so to say, and we see the 5G networks, the private 5G networks, coming into the different sectors, and industrial sector is very much in the forefront, Industry 4.0, as we mentioned already by several speakers, and also in the public space like warehouses when the connectivity aspects are increasing. One other aspect of this, the slides are not perfect in the display of them, so to say. But this integration that I mentioned into the vertical sectors, we can see also from this perspective, looking at the operational technologies that we are using in manufacturing, in transport, and so on, and the ICT tech areas as such, they are coming very much bringing the right requirements together in the use cases, in the future use cases. You see it from the reliability area, We have the ICT carrier grade, but in the operational and manufacturing and in healthcare, mission critical aspects, then really the reliability need to be stepped up. So it's a big increase in 5G, but already when we go into beyond 5G, this will be even more important for many sectors. The same with technologies. We are looking at specialized technologies in many sectors in operation technology areas, but also we see also the use of general purpose standardized technologies very much coming up in general in the networking, in the cloud sectors, the open networks, the open RANs, things like that. So the combination there between the technologies, how to handle that is also a big next or transformational part of the integration of network technologies in such and cloud technologies. Services, we go into different kind of services. We have from the operation side very much business process, but now we are going to integrate also the media information services, the data services, and also these kind of come together will create new challenges, which are very much dependent for the future of the different sectors. The technology sides, we are going with fast speeds in many times in the ICT sectors. Rapid technology developments, new processes coming in, the operation sectors or the manufacturing, we maybe have a slower take up of technologies, but this rate of technology change is increasing all the time. So we need to, this is also a trend, so to say, to come together and how to handle that in the beyond 5G, 6G perspective for the support of the vertical sectors. Another intel trend that has been mentioned, which is key, so to say, to the networking area as such, and also the cloud area, is that the intelligence is coming everywhere. This is happening with the AI perspective, so to say, more software-based intelligent services, so to say, and technologies. It is going on also into the open source, open network aspects, so to say, both on the software side and the hardware side. Again, more into the virtualization kind of networks with different kind of virtual functions which are virtual, and all is integrated into the cloud, so to say. And this is, we have the public cloud, we have the telco cloud, which are these kind of, we have also the edge cloud, so to say, which is getting more the content closer to the users to get the latencies that we have, that we need for different kind of application. All this is getting driven, so to say, by the intelligence of the AI, the data-driven aspects, so to say. So this is indeed additional activities now when we're going to from the telecom world into the cloud world, and we're going to integrate both into the future, and which is also driving very much the beyond 5G perspectives in the future. But when we look at 6G, and I think this is also mentioned several times from the recordings today by both from the EU and Korean side, maybe the main aspects that we will have to look at when we look at 6G is the societal challenges, all these effects that the 5G and beyond 5G technology will create as they are coming into the different economic sectors, vertical sectors, and societal areas, I would say, and such. We have to look at the energy efficiency. We have to look at the energy efficiency of the ICT sector as such, and also the networking sector. We have to look at the radio parts are the most energy, we use most consume most energy, so we have to look at the radio parts. We have to support that, and then also the capacity, so it will be that the massive fiber deployment is necessary, so to say, to address these issues. But the energy efficiency has to be handled on many levels, on protocols, architectures, sleep modes, which is all in 5G, but beyond that, and then also the microelectronics architectures, application level, and all levels have to be very much energy efficiency aware. So this is key aspects for all of us. But also the use of the 5G, beyond 5G technologies in the vertical sectors, in the other areas, is also an important part. So indeed, maybe the volumes of the ICT sectors will maybe not make it easy to stop the energy consumption. Maybe will even increase, but hopefully the help in the vertical sectors will offset this increase, so to say, in many folds, so to say, but by using the energy efficient ICT technology to support the vertical use by the virtualization, slicing, the cloud native architectures, the AI-driven service deployment, and open interfaces. All these are important aspects to look at that and how to use ICT as most energy efficient in the vertical sectors. Combine is a very important aspect of the societal aspects, the energy efficiency as such. Affordability, accessibility, we have to make sure that all these technologies can be affordable, so they can be used by as many as possible, and also accessible, the coverage aspect. We look at the satellite non-terrestrial network technologies has been mentioned as a key technology to bring the accessibility, the coverage more. But then we have to look at more of the affordability as well, and look at make those the network as such, even if all the networks are linked, but maybe make them affordable as well from the service software and all these aspects, so to say. And this indeed, we have technologies like cloud and open interfaces, and the softwareization as such is promising to look at that, but these need to be researched into and make sure that the promises will be held. Key for all with energy efficiency is a key aspect for accessibility of coverage is one. Is also one key aspect is also the trust and security. And this meant that the networks need to be trustworthy. And this is really, look at as I mentioned, network and networks. There are many aspects which need to integrate. So this is really to make sure that the networks and the data that they are transferring those are very trustworthy, so to say. And this is included in the end-to-end security aspect as well. We mentioned also the health aspect, the EMF control and electromagnetic field controls. We try to reduce the radiation levels as much as possible. And there are new technologies in the 6G is in horizon that will have potential to help these kind of aspects. With the cell-free networks, the protocol active modes, which will be sleep modes and things like that, and also different other wireless architectural technologies like the reflective intelligent surfaces and the directive antennas, something like that. So we hope that the EMF and health aspects will be lowered in the future, despite the volume or increasing, so to say. Yeah, and the final slide from my side, and look at to summarize a little bit, that we have started the HexaX project, which was mentioned earlier by Bernard. And there we have also looked at the first use case families, which are new, so to say, to beyond 5G, so to say. Not the 5G is still going into many vertical sectors, but we see also new use cases. Sustainable development, the energy efficiency in all sectors need to be embedded into networks as well. Massive twinning, we have looked at the immersive technologies, the extended reality technologies, and used in the manufacturing, but also going to other sectors, so to say, in the future. Telepresence, we are looking at Zoom today, but we can look at more efficient or more impressive future video conference system that we make even if you're not present physically, we can make the more telepresence more attractive, so to say. The robots, the collaborative robots, this is also very much in the aspect of the latencies of the vertical sectors, which were mentioned earlier, and the trust zones, which we need to be trustworthy. And when we have this kind of network to networks, we have body networks, we have local network, Wi-Fi, satellite, all kind of private networks, we need to make sure that these are trusted in overall when the users are using them, so to say. And the challenges below, I mentioned trustworthiness, sustainability, absolutely key aspects which need to be design parameters which are of importance when you're developing 6G. And then look at the capacities for the extreme experience, increase the coverage, connecting the intelligence, and bring all networks in a secure way together. So these are challenging. So thank you for your attention.
Thank you very much, Pertti, for this. This is a very good introduction, I would say, on these priority sectors and views for the future mobile technology. I would like to now move to the next speaker with Dr. Colin Wilcock, who's chairman of the board at the 5G Industry Association, to talk to us about the smart network services and partnership proposal and the technology focus for 6G. Colin, welcome, and the floor is yours.
Thank you very much, and thank you very much for the invitation to this event. So good morning, or good afternoon, or good evening. My name, as was said, was Colin Wilcock. I'm here representing the 5G Infrastructure Association, and at some point people will be able to, So our organisation tries to be the voice of European industry on all things 5G, and in the future, all things 6G. And when we talk about industry, we don't just mean the big companies, the Nokia, the Ericssons, the Huaweis, the Orange, the Deutsche Telekom. We also include the SMEs and the academics and the research institutes. So we have the whole ecosystem in our association, where we're trying to drive forward 5G and 6G technology. If I could have the next slide, please. One of the key things we do is, together with the European Commission, drive research in Europe. So for 5G, we have been jointly running with the European Commission the 5G PPP, which is this large research program which has been running since 2014 and has laid the foundation for a lot of things that we now consider 5G. So often in the telecoms world, we first create the name of something, and then later we decide actually what that means. Obviously, we have exactly that situation with 6G today. We have the name, but what 6G isn't actually defined yet. So in 5GPP, we managed to take that 5G name. We managed to create a lot of the major concepts within that first phase of projects. We then in phase 2 went on to try and apply that 5G technology to all of these vertical industries, these new domains. And we tried to work together with the key players in those domains, not just to find solutions using the existing 5G technology, but indeed to evolve and improve 5G to meet their requirements. And that is what we're now seeing in release 17 and release 18 in 3GPP. We're seeing a lot of features trying to support those vertical industries based on the trials and work that's happened in 5GPP. We then had a last phase where we tried to develop innovation platforms, trying to provide typically cross-national 5G platforms where new SMEs or existing players could try out their 5G ideas. And as part of that phase 3, as was mentioned in the previous presentation, we had a series of 6G projects, first 6G projects, trying to build a bridge between this partnership, this program, and the next one, and indeed trying to build a bridge between 5G and 6G. So if we move on to the next slide, please. Clearly, the evolution of cellular technology is not stopping. 5G won't be the end of the story. And within Europe, we have been putting together a proposal for a new program, a new research program called Smart Networks and Services. And this program has a broader scope than the previous program. So in the previous program, we were very much focusing on the telecoms and then trying to help the verticals. But in Smart Networks and Services, we're trying to bring together a number of different communities, not just the telecoms, but also areas like IoT, cloud, software, and a number of those key verticals into the proposal to make sure that we have the right areas of research moving forward. And we've had somewhere around 1,000 organizations involved in the preparation of this proposal from the industry side. In terms of funding, we are talking about roughly 900 million euros over the lifetime of the program for research and innovation, and another substantial sum for nearer term deployments like the 5G corridors along the motorways of Europe. If I could have the next slide, please. So what is Smart Networks and Services trying to achieve? Well, there's really a number of things which are central. The most central thing is trying to, in the first phase, create that fundamental technology for 6G. Make sure what the building blocks for 6G are, or indeed do the research to try out various different options and see which are best. Clearly, we need to look at new applications. We need to see where is 6G going to be applied. And we also wish to try and safeguard the sort of technology leadership that's available in Europe with the major vendors, and indeed European values. And by that, what we mean is there is a certain idea of personal security, personal privacy in Europe, which is perhaps stronger than in some other places in the world where these things are not valued. We want to make sure that 6G embodies those values, making sure that people or users' data is secure, that they can use these networks in a secure way with safety, that their data will not be leaked. And clearly, it's not just about the technology in isolation. We also wish to use this technology to digitize other industries, but equally try and further address a lot of the societal problems. So we're starting that with 5G, absolutely, but 6G hopefully will take us a step further. The sort of world we live in where it's ever more important about the environmental impact. It's ever more important about the urbanization, everyone moving to the cities, trying to make cities work from traffic to water to electricity to trying to make our world a better world through an integrated network which ties it all together. And clearly part of those ideas is also to go beyond a pure communications network. 5G is about communications, 4G is about communications. 6G will certainly be about communications, but it might well be beyond that. The ability to provide AI in any particular place, the combination with cloud, with massive computing potential, the ability to sense the environment and bring that together so that we link the digital with the physical world. Some of these are very exciting concepts. If we could have the next slide, please. So what do we actually have to study or solve? What are the key areas? What I've done here is I've tried to do a sort of brain map. What we have is a document called SOIA, which tries to map out in our area, in cellular communications. It gives a roadmap of what are the key areas over the next 7 to 10 years where we need to be developing, we need to do research. And this gives a quick overview of some of the ones that have been identified. It's a long document. I've just done a quick summary here just to give a feeling of the sort of areas that we will be investigating. If I could have the next slide, please. So let me talk about the draft for the first work program. So this is work in progress. This isn't finalized, but I wanted to give some sort of feel for what that first set of projects will cover. And potentially we're talking about quite a significant call, somewhere in the range of 200 to 250 million euros public funding for this first call. I will talk about timing in a minute, but what are we actually going to be spending that money on? Which areas are we going to try and research? Well, the first thing to notice is this isn't just about 6G. So yes, the majority of the funding will be going to 6G on the right-hand side, but equally there'll be substantial funding for 5G or 5G evolution. Why? We have not completed the 5G vision. 5G is still pretty much at the beginning of its story. There's still an awful lot of evolution to do. There are also a lot of work to do with the verticals to bring them up to speed, new verticals to add. There's work to do there. And that work is firstly in stream A about looking at evolution of systems and components and features, but it's equally about taking some of the things we've already developed and trying to have large-scale trials, trying to prove that they work in the real world, not just PowerPoint, but in the real world. On the 6G side, most of the money is clearly invested in, if you will, fairly fundamental technology of the key building blocks for 6G. But equally, there is a certain amount of money also looking at the next step. And in the next step, what we need to do is we need to take these ideas and we need to somehow bring them together into some sort of common experimental infrastructure if we can, that we can take the various building blocks that we have and somehow try and put them together, not necessarily in this phase, but in the next phase, the next call for projects. And that's why we have the stream C there. If I could have the next slide, please. I haven't got time to go into detail here, but what it's trying to say here is the various different streams, the various different parts I've talked about interact with each other. And over time, they provide input for the other streams. So I was talking about stream D, where we were actually trying to create these platforms to put proof of concepts on. They will then be used in the next phase, actually in the research projects. So we are having results from one stream in one phase feeding through to a different stream in the next phase. So we're trying to get some sort of pipeline here from fundamental research, proof of concept, large-scale trials, and then preferably on to the other thing, which I'm not talking about today, which is SEF2, actually first deployments. Okay, if I could have the next slide, which I believe is pretty much my last slide. I wish to just talk about timeline. So as was mentioned, the first European 6G projects are running, are up and going, and the first results have been provided. I would perhaps highlight the flagship Hexa-X, which has been mentioned before. This has delivered the first results. They are public, they are available on the website. It might be interesting to see those. But in terms of smart networks and services, the story really starts this year. So we are expecting in the third quarter, end of third quarter, beginning of fourth quarter, that we will actually publish the first work program. The one today I've given a high level draft overview. The actual detailed work program will be released September, October this year, we hope. Then the companies will need time to prepare those proposals and those will need to be assessed. And what we would imagine is that the actual projects will start somewhere around just before summer or just after summer next year. Maybe Q3 next year would be a good indication of when those projects will actually start. So that gives an idea of the timing that we are there. This cannot just be a European effort. Clearly, the 6G standard needs to be a global standard. And that's why we welcome collaboration across the world. We have strong Korean presence. We have Samsung on the board, our governing board of the 5G Infrastructure Association. Samsung is a member, and we welcome there. And we would welcome the chance to bilaterally work with Korea on 6G. The door is open. My contact details, I'm sure, will be available from this meeting. I would welcome further discussion of anyone who's interested. Thank you for your time.
Thank you very much, Colin, for this presentation and for this offer for cooperation. I will now invite our next speaker to take the floor, Dr. Andreas Müller from the 5G Alliance for Connected Industries and Automation, where he's general chair. And he will give us an insight about the future requirements for industrial automation. Andreas, the floor is yours.
Yeah, thank you very much, Xavier, and hello everyone. Also, very warm welcome from my side, and then really great pleasure to be here. Because international collaboration certainly is extremely important. It is important for 5G and also the further evolution towards 6G because it's a global standard. It's very important for the manufacturing industry and the industrial automation domain, which always used to be a global market and global industry as well. And so it's even more important for industrial 5G, and that's exactly what my presentation will be about, so 5G applied in manufacturing. So as has been said, my name is Andreas Müller. In my day job, I'm with Bosch, driving the industrial 5G activities there. But today I'm here in my capacity as general chair of the 5G Alliance for Connected Industries and Automation. And 5G ACIA is a global organization, of course. We're headquartered in Europe, but we already appreciate a very good collaboration with Korea. So KILT, the Korea Electronics Technology Institute, was one of the early members of 5G ACIA. We are very happy about this, and we also have very good relations already to the 5G Forum. So the first workshop that we had outside of Europe basically was in Seoul together with the 5G Forum before the pandemic, of course, but it was a very interesting and great event. And of course, I do hope that we can come back to Korea for one of the future meetings as well. So future requirements for industrial automation. Before I talk about the future, let me briefly recap why 5G and mobile communications then in general actually matters to the industrial domain, to the manufacturing industry. And basically what we have seen and what we are still experiencing is that we have two different major developments going on at the same time. On the one hand, it is the evolution of mobile technology towards 5G. And I mean, everybody here is certainly an expert in this. The new thing is that it's 5G, as has been said many times before, has a very strong focus on these new vertical applications in different domains, manufacturing being one of them, automotive, healthcare, agriculture, you name it. And of course, this is enabled by the new capabilities of 5G, like the low latency, the high reliability, massive machine type connectivity, and so on. Now, at the same time, and this started independently of 5G, we have these developments towards the fourth industrial revolution, Industry 4.0. This year, we just celebrated the 10th anniversary of Industry 4.0. So this started 10 years ago. And connectivity per se is a key enabling technology for that, so that we can establish cyber-physical production systems and merge the physical world of production with the virtual IT worlds and enable new concepts like digital twins and so on. And now it's quite natural and straightforward to bring these two different developments together. So to use 5G as a connectivity fabric in the factories of the future. And this way we can lift Industry 4.0 to the next level and achieve unprecedented levels of flexibility, efficiency, productivity, and also ease of use, so to support the people working in the factory in a very intuitive and ergonomic way, for example, using AR, VR headsets and wearable devices and similar things. So that's on one slide, the big vision that we have. Just a couple of words also on 5G ACIA in case that not everybody knows what we are doing. So 5G ACIA is the global forum for bringing all relevant stakeholders in the context of industrial 5G together. This primarily includes the ICT industry, the network operators, infrastructure vendors, chipset providers, and so on. But on the other hand, also the so-called OT industry, operational technology industry, which includes the machine builders, factory owners, industrial automation, component providers, and similar organizations. And this has also been mentioned before already, so maybe we should call it the ICOT industry. But basically, it's about bringing all relevant stakeholders together and then to jointly drive and shape the developments towards industrial 5G. So this starts with the establishment of a common language. We want to make sure that the needs of the industrial domain, the manufacturing industry, are reflected in standardization and regulation, that we jointly understand how we can optimally make use of 5G in the factories of the future, and also address many other relevant aspects that are needed in order to build up an ecosystem and get the ball rolling, basically. And the last general slide on 5G ASIA, this is an overview of our account members. So as of today, we have still 85 member organizations, really a good mixture between the IT industry and the OT industry, and also from different geographies around the world. And we are still growing, so I'm already looking forward to some announcements in the next couple of weeks, since we will get a couple of new member organizations, and among them some also very familiar and big names. And this is, of course, what 5G is all about, to bring all the stakeholders together. So where are we now if we look at 5G at first? 5G today is a reality. Many might already have 5G smartphones in their pockets. The networks are being built up. Korea, of course, is always one of the front runners in this respect. But what we have today is basically consumer 5G. So the evolutionary development of 5G, higher data rates, the strong focus on mobile broadband, this is where we are today. This is a reality. But we also have to be honest, so the potential for the ICT industry to increase the revenues is very limited. It's more about securing the current business, but typically end users are not really willing to pay more just because it's 5G. The expectation is that you can get higher data rates, better service, basically at the same price. Therefore, the average return per user usually does not change much with new generations. With industrial 5G, we are a little bit lagging behind, so we are not there yet. But there are good reasons for this, which I will briefly outline. Of course, it's more revolutionary, so there is no track record of using mobile communications in a factory. If we now want to use 5G and in the future 6G in a factory, of course, there are many things that first of all have to be prepared and built up and so on, and that's why we are basically not there yet. But the promises that we see, the prospects are really significant. So we have also here seen this on the previous slide, for example, an estimate of the number of factories worldwide, which were more than 10 million. If we add warehouses as well, then we have another 3 million. And if you then think about only half of them being equipped with a 5G network in future, I mean, then we are talking about a huge market potential for the ICT industry, but also for the OT industry, because as I mentioned before, there is the perspective that we can increase the productivity, the efficiency, and so on. And if you only can increase the productivity by 1% or so, this is really huge numbers if you look at the overall economy. So therefore, there's a lot of economic potential behind industrial 5G, but it takes a bit longer, a bit more time than maybe originally expected, but also especially compared to the consumer. And that's also what I want to make clear, and basically along the lines of what Colin already mentioned in his previous talk. There is still work to be done towards 5G, also industrial 5G. And of course, it will also be, from my perspective, at least a transition, right? It's not a step function then. With 6G, everything will be completely different, but we have this evolutionary path, hopefully, and then maybe some revolutionary elements are added as well. But first of all, we should also make sure that we get the full promises of 5G. And the same applies to many other vertical domains certainly as well. So some started even later than 5G ACIA and industrial 5G, if you look at healthcare and other areas. So that also will still take a bit of time. So why are we lagging behind with industrial 5G? Well, the basic reason is because we started later. 5G ACIA has been established in 2018. So just 3 years ago, and this is basically was the starting point of a really stronger engagement of the industrial domain. And of course, the ICT industry already started in 2012 around that year with the early research activities on 5G. So I think this already explains some things. Also, I mean, a lot of momentum. We've seen a lot of momentum with HVP, so they picked up many of the use cases and requirements that have been brought in by industrial players, by 5G SAE. We are very happy about this. Many features have been specified for supporting the specific requirements, like ultra-reliable low latency communication, support for time-sensitive networking. Now with release 17, also this NR RedCap reduced capability mode. So all these are important building blocks that can help to provide value in a factory. But many of these building blocks come only with release 16 or even release 17. And of course, we don't have any products yet. So the standards for release 16 at least have been finalized. Now it's being implemented. First chipsets have been announced, but we're still waiting for the infrastructure upgrades, the modules and so on. So there is still not much equipment available that you can use here. And this, of course, is then what really makes a difference to the industrial. There's also support for special needs needed. Basically, of course, there's a lot of momentum and interest behind these private networks or non-public networks. And I was happy to hear that also Korea is now discussed in more detail. But also this takes a little bit of time until we have established operating models, until the business models of also the network operators and so on are adjusted. So these are really more revolutionary changes. There's still a lot of performance validation to be done in real-world factories. Also, this has been mentioned before. We have these different innovation cycles. The industrial domain is not so famous for being the fastest industry. In some cases, it's a very conservative industry. And somehow we have to adjust and to align these different innovation cycles to find a common speed. The ecosystem has to grow from scratch. It's not just having a base station and a chipset. So 5G alone does not provide any value. The value comes from the use cases. And the use case requires then also robots, automated guided vehicles, and so on, being equipped with 5G. So that takes some time to build this ecosystem. And we have a chicken and egg challenge, basically. So the question, who will do the first step? Will it be the factories deploying 5G networks, or will it be the component and machine builders and so on providing equipment with 5G? So that's something that still needs to be seen. So I think I have to speed up a bit. So the last slide basically gives now a little bit of perspective of the view of 5G SAE towards the future development of industrial 5G towards 6G at some point in time. And we identified so far 10 aspects basically that we consider to be important here. And the first one, and also this has been mentioned several times today, from our perspective, this focus really should be very much on vertical industries, like it started with 5G. In 5G, from my perspective, first of all, still the consumer domain was in the focus. And then basically on top of this, the vertical industries. In 6G, maybe the vertical industries should come first, so to say. So that is really the center point of all considerations. And this includes manufacturing, but also many other verticals as well. The same applies for non-public networks. In 5G, we started with the established public networks, which is the main focus. Now, together with these new vertical applications, which often require only local connectivity, non-public networks really experience a huge momentum. And also here, there's still much more that can be done to optimally support this. It's about security, it's about regulatory changes potentially, and also new business and deployment models. And also this should be in the center of further considerations here. Also then innovations on the management plane, sophisticated self-management, using artificial intelligence, for instance. Also this is something that has been mentioned before. For example, to simplify the operation of such non-public networks, but also to ensure a high level of resiliency, right? So that if something fails, that we have to some extent at least some self-organizing features, that we can have self-healing functionalities and so on, maybe assisted by AI, so that we have a high level of resiliency and availability that we need in manufacturing. Backwards compatibility is an important aspect. So the life cycle of or lifetime of machines in the factory can be 10, 15 or 20 years. If we now integrate 5G mobile communication technology, we want to make sure that we don't have to replace a complete production line only if in 10 years a 5G module breaks. So the equipment should be backwards compatible, and also this ensures then investment security, basically, which is always important for the initial investment decision as well. Flexibility, modularity of the equipment is another important building block here, because manufacturing is a very heterogeneous field. We have the process industry, we have discrete automation, discrete manufacturing, we have warehousing, and I mean, all this belongs somehow to manufacturing, but these can be quite different areas with different use cases, different requirements, and therefore it would be important that we can tailor the equipment to the needs of the specific deployment scenario. Of course, there is also a need or a wish for a better quality of service. Maybe it's not, from my perspective at least, the most relevant ones, but there are still use cases and applications in manufacturing where even 1 millisecond latency is not enough. Or we certainly can make use of even higher accuracy positioning down to the centimeter level. So this certainly can provide additional value as well. We have the developments towards Open RAN that are ongoing, so that we have disaggregation of the RAN, open interfaces, and also fully virtualized infrastructures. And this is also something that should be continued and maybe emphasized towards 6G. And this goes hand in hand, of course, with the flexibility, modularity, especially if it's all software defined and virtualized, then it's very easy maybe to have a building block that optimizes certain aspects that we especially need in manufacturing. And at the same time, of course, this also helps new entrants, new players to maybe offer such tailored solutions and building blocks to the customers here. Advanced additional functionalities, also this is very promising. If you look at terahertz technology, integrated sensing, also this has been mentioned before, the Internet of Senses as a buzzword here. If we have these additional features inside the 5G or future 6G system, then we can use it for quality control, quality inspection, for imaging, for radar applications, and there are many things you can do with these features that in a factory. Sustainability and efficiency certainly is a very important goal as well, also from the perspective of 5G SAA, to support the SDGs, as has been mentioned before. And what we should also think about is if we can make it easier for verticals in general to get directly engaged in 3GPP. 5G SAI has been established to provide somehow a bridge between the OT industry and also 3GPP, but still it would be much better from the perspective, at least, of the OT industry if also direct engagement is simplified. And so we should rethink maybe the way we are doing things in 3GPP. So if there are ways to enable this, and I think this at the end of the day would be of benefit for the entire ecosystem. So I think I used a little bit more time than scheduled. Apologies for that, but with that I'm will be done. So thanks a lot for having me here today.
Thank you very much, Andreas, for the presentation. Very instructive and helpful, I think, in the context of this exchange. As a next speaker, I will welcome David Boswatik, who is Director of New Technologies at ETSI, and who is going to talk to us about the global standardization roadmap beyond 5G. David, the floor is yours, and we can see your slides. You're all set.
Excellent. Excellent. Thank you, Xavier. Thank you, everybody. Good morning, everybody, and good afternoon. My name is David Boswatik. I work for ETSI. My job is Director of New Technologies, which basically means I am responsible for looking at the evolution of technologies in the industry, building stronger links with research and standards, and also welcoming new areas of work into ETSI. I recognize that we're running late, and normally I only have 10 minutes, so I will go as quick as possible. My presentation is broken down into two parts. One, I was asked to present a very quick status of 3GPP release 17 and 18, and two, which is where my competence really is centralized, is looking at the ETSI approach to research and standardization for beyond 5G and towards 6G. So without further ado, I'll quickly go into the status of 3GPP standardization efforts on 5G, So obviously, a quick resume that 5G is a multiple release generation, starting from release 15, where we saw the initial definition of new radio, moving on to release 16, where we completed the 3GPP IMT 2020 submission, and now looking at release 17, where we are looking at adding in new functionality. And also then the future release 18, where we'll look at completing more functionality for 5G. The recent news is that 5G Advanced is the new name of things as of release 18. So from release 18, we'll be using the name 5G Advanced in our future releases. And of course, 5G will extend beyond release 18, so to release 19, release 20. We do not know precisely where release 5 will end. So looking at the release 17 schedule, I won't go into this in much detail because we don't have much time, but it's important just to note that the global pandemic has impacted the way 3GPP produces specifications, has meetings, or in fact has electronic meetings. So everything that is done by 3GPP depends on the development and the resolution of the current global pandemic. We can see the current timeline for 3GPP completion is looking at the end of Q4 2022. But of course, that can change depending on the current situation. If we can get back to face-to-face meetings for 3GPP end of this year, beginning of next year, that will obviously help with the progression of the one standard for 5G. Looking to the future, well, obviously, release 18 studies are underway, and the full content of release 18 should be provided by the end of this year. In order to discuss what will be included in release 18, there will be a workshop, a RAN release 18 workshop at the end of this month, 28th June to 2nd of July, which is already ongoing because there's a large amount of email discussions to ensure that the contributions are mature enough when they go into that very important RAN release 18 workshop. They're looking at three main areas: EMBB driven work, non-EMBB driven work, and then things that will work above both use case families. It's important to note that the workshop will be well balanced, looking at immediate short-term requirements and also the longer-term commercial or market requirements. Okay, that's it for the very short 3GPP presentation. Now into something where I'm more competent to speak, let us say. This is the ETSI research and standards approach. So what we're looking at now is beyond 5G, or the evolution of 5G, and on towards 6G. It's very important to note, and it's a message I always give in external presentations, is that global operators are currently deploying 5G networks across the globe. This is what's happening today. It's important that when standards bodies and others use the term 6G, that we don't dilute the impact of the present 5G rollouts. 5G will certainly be with us for at least another 10 and more years. In ETSI, we only really speak of research and pre-standards work for candidate beyond 5G, 6G technologies. The 6G standard will eventually be defined by 3GPP. As I mentioned previously, release 18 will see the 5G midpoint, named 5G Advanced, which gives us an initial timeline for the technology roadmap for 5G evolution and 6G. And here I think it's interesting to share European visions and other visions, just to make sure we're working on the same timeline. This is the output of a recent European project, Empower, which shows 6G work items, so study items in 3GPP, not really being expected before 2025, 2026. The current assumption being that we will not see deployed services for 6G before 2030. But as I mentioned, this can always change due to market pressure, global pressure, so we have to remain flexible. All of these dates are just estimates and projections. And also very important to note that 5G evolved and 6G development will run in parallel for several years to come. Very quickly, I won't go into this in much detail. This is ETSI's sort of summary of what we've read in relation to use case, requirements, and even architecture. So it's a summary of what is out there. from various white papers and research results. So we can see that 6G will enable a fully automated society. It will include holographic type communications and tactile multi-sensing communications. Obviously, this will extend AR, VR to more multi-sensory extended reality applications and look at connecting multiple things, different things, not just telephones and cars, but we're looking at robotics, autonomous systems, and numerous autonomous things, in fact. With the extension of radio technologies, we can imagine that new use cases will arrive due to the ability to do indoor and outdoor accurate positioning and indoor and outdoor sensing of the environment around us. So we can see use cases possibly like smart working based on this seamless holographic projection, and also smart design. So in going back to the industrial aspects, looking at real-time digital twins and the massive twinning aspect. Also, we've heard several times the moving away from simply Internet of Things and Internet of Everything to the Internet of Senses, and I've heard recently today the Internet of Experiences, so you can experience connectivity and services. To meet these use cases, 6G must provide connectivity, as mentioned several times, terrestrial, undersea, airspace, and full space coverage. It needs to fully integrate advanced artificial intelligence throughout the networks, from the handset to the application, and from the handset to the core, and also consider privacy and security as a core component, which may be something we could have done better in 5G. Looking to early performance targets, I think it is really too early to define what the KPIs for 6G will be. We cannot define it, but we can at least have a vision, have a projection. So here we can see several papers and several sources who are quoting various performance targets, including the famous peak rate download at 1 terabit per second. It's useful to note these, it's useful to share these, but I think it's very possibly even dangerous to define these as the strong target for 6G. Looking at the architecture, there's several projections of 6G architectures out there. I think it's interesting to retain that the 6G architecture, as was mentioned previously, will be a more three-dimensional architecture. So we'll be looking at connecting more in the space area, so satellites, HAPs, UAVs, and the air area, and also integrating underwater communications, either by cable or by projected waves. This means that 6G will again be a heterogeneous network of multiple networks. Again, we can imagine it will be software-based, AI-controlled, and also having distributed AI-native elements throughout the entire network. Again, as we said, autonomous means that you have a zero-touch approach, which is also an extension of current 5G approach, and fully autonomous. Again, we can see the cloud is an important element, but again, pushing these cloud elements to the edge and then pushing the edge even further out towards the end user. And also the concept of having or including elements which are cell-less, so moving beyond the cellular architecture approach. These gives us several key attributes: secure by design from the beginning, not as an afterthought, greater coverage in the 3-dimension, and also moving out to the, I think it was used as shadow areas, out to the fully rural areas, and also being efficient, energy efficient, but also resource efficient. So spectral energy resource, spectral usage resource, and also recycling materials in the network and in the handset. So fully resource efficient. What we can see, so in our readings and our researches, we've been looking mainly at European research areas. As we've mentioned, Networld Europe has a strategic research and innovation agenda. And that maps several areas of potential ongoing research and future research. The HEXA-X, the Horizon 2020 6G flagship, is looking at areas of technology which may be included in 6G. The initial draft work program of the European SNS joint undertaking has indicators of where technology may need to go in the future. These are all indicators. And what we've done, we've looked at some of those main areas. So to go very quickly, so pervasive AI, native AI design, moving the higher frequency bands away from above millimeter wave 2 sub-terahertz and full terahertz is where you see the sensing and the positioning ability added in. Cell-free, massive MIMO, which is an evolution of 5G. XR, senses and holographic communications. Full implementation of blockchain and distributed ledgers. Moving beyond quantum key and quantum safe into fuller quantum communication. So there's obviously areas of research there. Optical wireless communication, visual light, Li-Fi, all of these may be elements of communication in a future 6G network. And then moving into the spatial area, low Earth orbiting satellites, CubeSats, UAVs and HAPs. I put this one last, but it's not least, reconfigurable intelligent surfaces. There were many European projects looking at that area. I think there were 8 projects, and they are considering bringing the results of the research into early standards in ETSI. So we're looking at building an ISG, which will consider the output of those European projects, the output of some projects from the UK as well, and building early standards, which can then be used by 3GPP in 4 to 5 years' time, when the time is right to fully define reconfigurable intelligent surfaces as an option in 6G. Quick conclusion, sorry. As we move forward through beyond 5G and on towards 6G, I think the key areas are cooperation between all, communication, so making results very public and open to all, and then coordination between standards bodies, research, policymakers, but also between regions as well. I always repeat the message, 5G is the now generation, and for the coming years, 3GPP will be focusing on the evolution of 5G, advanced and beyond. 6G will most probably deployed around 2030, plus or minus a few years. And an evolved 5G will coexist alongside that. But now is the right time to be looking at what technologies are required to be included in 6G, and also sharing globally our 6G visions and timescales. 6G will most definitely be more than simply better and faster 5G with a bit of AI. But we still don't know precisely what 6G will contain, which is why research is ongoing and sharing visions between all parties is very important now. Speaking as ETSI, we believe we have an important role to play in linking the output of research projects into pre-standardization activities that can then be fed on into global standards bodies such as 3GPP, ITUT and others. So now is the right time to do that. And with that, I would like to say thank you very much. That's the end of my presentation. Thank you.